is GATE 2016 set 2 electrical question number 46. A 3-phase voltage source inverter as shown in figure is feeding a delta connected resistive load of 30 ohm per phase. If it is fed from a 600 volt battery, it is the DC link voltage is given with 180 degree conduction of solid state devices. The power consumed by the load in kilowatts is being asked. For NPTEL reference, you can refer to lecture number 19 voltage source inverters of the NPTEL course Power Electronics by Professor G. Bhuvaneshwari, Department of Electrical Engineering, IIT Delhi. Now for useful data, you need to know that for 180 degree conduction mode of a voltage source inverter, the V phase is root 2 VDC by 3 and line voltage is whole root over 2 by 3 into VDC. The 3-phase power for a 3-phase AC circuit is given by 3 times V phase square by R. V phase square by R gives the per phase power and into 3 gives the net 3-phase AC power. This is valid for star connection because in star connection the voltage impressed across every R element is V phase. However, for delta connection the voltage impressed across every R element is equal to V line. So that formula for delta connection will become V line square by R. So it's for delta connection. So be careful with the connection type. Now coming to the solution, since we know that the phase voltage at the output of the VSI for 180 degree conduction mode is equal to root 2 by 3 VDC. So it is root 2 by 3 into the VDC, that is the battery voltage, 600 volt battery at the DC side. So the RMS value of phase voltage is coming out to be 282.8 volts. In the question, since it is given the load is delta, then the voltage impressed across every resistance is V line. Now V line is V phase times root 3 and the value of R is given to be 30. Now V line square divided by R into 3 is the P net for delta connection. The simple rule is across every R element you need to find the voltage and that square divided by R will be the power and that times 3 gives the net power. So now V line square is V phase square into 3 into 3 divided by 30, which is equal to this P net, so which is equal to 24,000 watt or 24 kilowatt. So the answer is 24 kilowatt.